Welcome to David Alexander Maths Tuition. This is chapter 9D, the product rule. Okay, so let's take a look at the product rule in action. Now, one way to differentiate this, and this would not be a very smart way, would be to expand this bracket, but it's a bracket to the power of 4, so that's 4 sets of brackets. Expand all that out and then multiply through by 3x, but that's going to be a lot of work. Now, I'm going to take the 3x, I'm going to take the 1 plus 7x to the power of 4, and we're going to differentiate them separately. 3x will differentiate to 3, and 1 plus 7x to the 4 will become 28, 1 plus 7x cubed. If you're struggling on where the 28 is coming from, 4 comes down to the front, so that would have been 4 lots of 1 plus 7x to the power of 4 multiplied by the derivative of 1 plus 7x, which is 7, and 4 times the 7 is that 28. Now, dy by dx is straightforward from here. It's just these two bits combined plus those two bits combined. So 3x times 28 lots of 1 plus 7x cubed can be written as 84x lots of 1 plus 7x cubed plus 3 lots of 1 plus 7x to the power of 4. So there is our formula for dy by dx. Now we could factor out we can see we've got a 1 plus 7x and another 1 plus 7x here. So we can factor out the lower power, so that's 1 plus 7x cubed. That will come out the front, leaving 84x plus 3 lots of 1 plus 7x. And of course that is 1 plus 7x cubed, lots of 84x plus 3 plus 21x, which is 1 plus 7x cubed. 84x plus 21x is 85,105x plus 3. So in an exam they might insist on it being written in this format, but if you're using the derivative, then it's perfectly acceptable to use any of these equations that I've written down. Okay, so let's take a look at another example. I've got an 8x squared and I have a 5x squared plus 2 to the negative 3. So let's differentiate them both. That's going to be a 16x. That's going to be minus 3 5x squared plus 2 to the negative 4 multiplied by 10x. So in other words, that's going to be minus 30x, sorry, that's a 0, lots of 5x squared plus 2 to the negative 4. Okay, so I'm going to combine these two together. So that's 30 times by 8, which is negative, so dy by dx is minus 240x cubed, 5x squared plus 2 to the minus 4 plus 16x 5x squared plus 2 to the negative 3. Done. But we might want to factor out the lower power here, so we can take out the 5x squared plus 2 to the negative 4, and that will leave me with minus 240x cubed plus 16x lots of 5x squared plus 2. So quite often when probably always when we're doing this factoring, we'll just end up with this bracket to the power of 1, and the reason why is because we've just reduced it by 1 when we're differentiating, which saves you the thinking about, well, what is 5x squared plus 2 take away 3 divided by 5x squared plus 2 to the power of negative 4. Again, we can expand this bracket out, so that's minus 240x cubed plus 80x cubed plus 32x, and so we can write that as 32x minus, struggling on this bit, 160, I believe, 160x cubed, there we go. So 5x squared plus 2 to the minus 4, lots of 32x minus 160x cubed. So we can write it, again, depends on how the examiners want it. It's perfectly acceptable to use this formula here, but of course we can use that as well. In fact, we could write it as 32x minus 160x cubed, and since this is a negative power, we could put that on the bottom as 5x squared plus 2 to the power of 4. So a lot of the time these equations can be written in many different ways. Okay, here's another example with an e function, so that's e to the 3x, and we've got a trig function as well, so that is the sine of 2x plus 4. So the derivative of e to the 3x is 3e to the 3x, and the sine of 2x becomes 2 cos 2x, and the 4 vanishes. So we'll just chuck these two together. So I can write that as, well, dy by dx is, I'll put the number first, 2e to the 3x cos 2x plus 3e to the 3x sine 2x plus 4. And we are done. We could take out the e to the 3x factor. In fact, let's just do that just for the sake of it. Dy by dx is e to the power of 3x 2 cos 2x plus 3 sine 2x plus 4. Put the 2x in brackets, otherwise people might think it's the sine of 2x plus 4 rather than the sine of 2x and then add the 4. I'll put a bracket around the 2x in the cos as well. There we go. So two equations, doesn't matter which one you use, unless the exam specifies a particular format. Okay, so here we've got two trig functions. So I'm going to write the cos of 5x and the sine of 2x. The derivative of cos is minus sine, so that's going to be minus 5 sine 5x, and sine goes to cos, that is 2 cos 2x. So let's combine these two. So dy by dx is cos 5x multiplied by the, there's a 2, so I'll chuck that at the front, cos 5x, 2 cos 5x, cos 2x. Now the 5x and the 2x, we can't do anything with that, we'll just leave it as it is, and plus minus 5, so in other words minus 5 sine 5x sine 2x. And of course it doesn't really matter if you put the cos 5x after the cos 2x, and similarly it's the same thing. Can we do any factorising or anything here? No, it's probably best if we just leave it as it is. Okay, so exactly the same thing going on here, except we've got some slightly harder things to differentiate. So we've got the ln of sine x and the cos of 1/2 x. So the ln of sine x is going to be something over sine x, and the numerator is the derivative of sine x, which is cos x. We could turn it into cot x maybe. So in fact, why don't we do that, because it's just a bit easier, isn't it? Let's turn it into a cot x, and the cos of 1/2 x becomes minus 1/2 sine 1/2 x. Okay, so let's chuck these two together. So it's going to be minus 1/2. So dy by dx equals minus 1/2 sine 1/2 x ln sine x. I could have written minus 1/2 ln x sine 1/2 x, same thing, plus cot x cos 1/2 x. And since the first term is negative and the second part is positive, it might be easier if we just wrote it as the cot of x multiplied by the cos of 1/2 x, take away 1/2 sine 1/2 x ln sine x. There we go, and we're done. Okay, so here's an example where we just need to work out the value of dy by dx. We're going to use the product rule because we've got two functions here. So I've got an x squared and I've got a 2x plus 3 to the power of 4. So the derivative of x squared is 2x, and the derivative of 2x plus 3 to the 4 is 8 lots of 2x plus 3 cubed. So let's chuck these two together. So dy by dx is 8x squared lots of 2x plus 3 cubed plus 2x times 2x plus 3 to the power of 4. Now we can just substitute 3 into this formula, or we can factorise. I'm going to factorise just for a bit of extra practice here. So that's going to be 8x squared plus 2x lots of another 2x plus 3, which is going to be 8x squared plus 4x squared plus 6x, which is 12x squared plus 6x. And I mean, I could take out a 6x as well here. So dy by dx is 2x plus 3 cubed. Factorising out 6x will leave me with 2x plus 1. So I've gone to quite a lot of extra work. Maybe it would have been easier just dumping the 3 into this equation here. Anyway, what is the value of dy by dx? Well, it's so x is 3, so 2x is 6, 6 plus 3 is 9, so it's going to be 9 cubed multiplied by 6 times 3, which is 18, multiplied by 2 lots of 3, which is 6 plus 1, which is 7. Okay, so 9 cubed multiplied by 18 multiplied by 7, so it's quite a big number here. So dy by dx, probably in an exam you wouldn't get one with quite such a big number for the gradient here, 91,854, so pretty steep. So there we go. So as I said, there was a lot of factorising that we did there, not strictly necessary because the question's not asked us to write the derivative in a particular way. We could have just substituted the value of x equaling 3 into the first equation that we made. So here's a question where we've been asked to find the stationary points. So we need to remember that the stationary points is when dy by dx equals 0. So we've got an x plus 3 and we've got an x plus 5 cubed. So let's differentiate them. Both x plus 3 goes to 1 and this goes to 3 lots of x plus 5 squared. Nice and easy. So let's chuck these two together. So that's 3 lots of x plus 3 x plus 5 squared plus x plus 5 cubed. I'm going to factor out, so I should probably write that this is dy by dx. So dy by dx, I'm going to factor out the x plus 5 squared, so that's x plus 5 squared, lots of 3x plus 9 plus x plus 5. So dy by dx is x plus 5 squared, 4x plus 14. So I need to set this to 0. So x plus 5 squared, 4x plus 14 equals 0. Okay, so therefore it could be 4x plus 14 that equals 0, in which case 4x is negative 14, in which case x is negative 14 over 4, or minus 7 over 2. So that's one x value, and it could be, well, the other one is x plus 5 squared equaling 0, so x plus 5 equals 0, so x is negative 5. So these are the two x values. Now for the y values, we just need to substitute it in, so minus 5 plus 3 is minus 2, let me just make a note of that, so minus 2 multiplied by minus 5 plus 5 is 0. Okay, so one coordinate is going to be minus 5, 0, and using negative 7 over 2, so negative 7 over 2 plus 3 multiplied by negative 7 over 2 plus 5 raised to the power of 3, I'm getting minus 27 over 16. So these are the stationary points, minus 5, 0, and negative 7 halves, minus 27 over 16. So there we have our two stationary points. And here's a final example where we need to find the derivative, but we need to write it in a certain way, which is good news, because if you hit this, you know you've got full marks, and if you don't hit this, well, you just need to keep hacking away until you do get this, basically. So we've got a 5x cubed, and we've got a 3x plus 7 to the power of 4. Let's differentiate them both. So that is 15x squared, and this is 12 lots of 3x plus 7 cubed. So let's combine these two together. That's going to be 60. So dy by dx is 60x cubed, lots of 3x plus 7 cubed, plus 15x squared, 3x plus 7 to the power of 4. So the first thing I'm going to do is I'm going to take out the 3x plus 7 cubed from both, which just keeping my eye on this a little bit, although I'm not obsessing about it. I'm just going to go for it and hope that I end up with that, basically. So 3x plus 7 cubed, and that will leave me with 60x cubed plus 15x squared, lots of 3x plus 7. Now I could expand this out, however I can see here that I can factor out an x squared and a 15. So dy by dx is 3x plus 7 cubed. So that's going to be 15x squared, and if I take 15x squared out of a 60x cubed, that will leave me with a 4x. and if I take the 15x squared out of the 15x squared, then that just will leave me one lot of 3x plus 7. So therefore dy by dx is 3x plus 7 cubed, 15x squared, and this is 7x plus 7, and we can factorise that into 7 lots of x plus 1, so I'll just, because I'm running out of space here, so that's 7 lots of x plus 1. So I've got the x plus 1, I've got the 3x plus 7 cubed, I just don't quite have the 105x squared, but if I multiply 15x squared by 7, let me just double check what's 15 times 7 is indeed 105, so therefore dy by dx is 3x plus 7 cubed, 105x squared, x plus 1. There were other options with the factorising which would have yielded the same result. That's just the sort of slightly random way that I've gone about it. You could have perhaps taken a different pathway, but whatever you do, you should have ended up with 3x plus 7 cubed, 105x squared, and an x plus 1.